Hi, welcome to Math as a Language. In today's video, we're going to identify angles. Identifying angles. Let's start with our undefined terms, our point, our line, and our plane. And of course, our angles. Angles are, well, let's start here with our line. If we take a look at a line, and we take this point and place it on the line, and we're going to make it a little bit bigger and color coded so that we can see it. That'll do, that's fine. So we're going to call this point P. So point P is on line, let's say line L here. Alright, now so point P is on line L. Now one of the first things we want to recognize is that this point P has established two rays. A ray would be a line that goes on in one direction only. That is to say, so this would be a ray going in that direction from point P, and then we'll color code it. We'll have another ray going in this direction from point P. So the one thing that we can talk about is the fact that the line, we can say that this line L is made up of opposite rays. Opposite rays. And when you name your rays, you can name your rays this way. We'll need another letter here, so we're going to go ahead and make this a sizable point here. Let's put it there, a little bit bigger so we can see it. So let's see, this is a good size. So we'll have a point P, and let's go with a different color. Let's go with a point S here. So point S, make it bigger. Alright, there you go. Point S going in that direction, and then we'll have a point Q going in this direction. So here we have it. So let's name our opposite rays. So the opposite rays that we're talking about to form this line, we would have ray PS. So ray PS, and remember our rays start, this endpoint has to match up, has to be paired with the originating point P, that endpoint, and S indicates the direction of the ray. This would be ray PS, and then we'll have our another ray, we'll have our ray PQ. We'll go ahead and use ray PQ. So PQ, again the initial point is P, it goes in the direction of Q, and our arrows make sure it points in that direction. So we'll just say here that, let's get the size of our, okay, so ray PS and, we'll use this symbol for and ray PQ are opposite rays, opposite rays. Alrighty, there you go. So we have that. Let's go ahead and kind of put this aside. So we have our opposite rays. Now, since we are talking about angles, we might as well make the point at this time is to recognize that these two opposite rays do make up an angle. Alright? Then that angle, if we take a look at this angle, whenever you have a straight line and opposite rays, that's referred to as a straight angle. So this would be a straight angle. That's the first angle that we will introduce here, the straight angle. And we're going to introduce also the symbol that we use, most textbooks use for angle. That would be this guy, little angle symbol. Alright, so that would be a straight angle. So the first thing we have, that's our first angle. So a straight angle would be essentially an angle that's made up of opposite rays. So now let's go ahead and name this angle. One of the things about angles is, in mathematics and geometry in particular, if you have a straight angle, this vertex P, that point P would be the vertex. Point P is your vertex, and that vertex would be the middle point of the angle. So let's just go ahead and, when we name our angle, this straight angle that we're talking about here, This would be angle, and we'd use this symbol for angle. This angle would be angle. Now it would be angle QPS. So we're going to go ahead and say that this is angle. Well, let's go ahead and use it all to one color. Q, angle QPS is a straight angle. And notice that that vertex value, that vertex point must be in the middle of the 3 points that you would use to name the angle. So angle QPS with P in the middle. P is the vertex, and that vertex must be in the middle of the 2 points that are the middle of the 3 points that you're using to name the angle. All right. Alright, let's see. Okay, now a more traditional angle. That's a straight angle, and again, this is a unique case, if you will. Now, let's look at a more traditional angle. Traditionally, you'll have an angle. We'll go ahead and use this angle, and you'll have a ray going this way, perhaps, and we'll have another ray going this way. Now, we're going to use different colors only for the first few of these. We won't do this all the time, but again, that would be a ray going this way and a ray going this way. Now, and that of course would be our angle. So this angle, now let's, rather than saying this angle or that angle, we're going to go ahead and number this angle, and we're going to put a number right here. So this angle 1, so angle 1 is the angle, is an angle. And an angle, for the most part, the definition of angle, an angle is the union of 2 rays, with a common endpoint. They have to have a common endpoint. So this point, that vertex would be that vertex is the common endpoint. So that vertex is the common endpoint. Of these 2 rays, you have the ray here and a ray there, so that vertex would be the common endpoint. So the angle, the definition of angle is the union of 2 rays. The union of course means that we're bringing them together, the union of 2 rays. Alright, so an angle is the union of 2 rays, and more often than not we can, let's draw another angle. This angle 1, let's go ahead and use the same angle 1 here actually, because angle 1, we can name this angle 1, or another choice would be to name the angle using 3 points, and we're going to make these points a little larger and distinctive so we can identify them. So let's go ahead and let's say that we're going to use this point here. Let's make it a little darker, another point here, the vertex that we've identified before, and a point here. Alright, so now we can use angle 1, or if we want to use other letters, we can call this angle X, Y, Z. Now notice something, you can identify the angle with a single number, alright, or some identifier, usually it's on the interior of the angle, or you can use 3 points. So angle 1, let's go ahead and do this. Angle 1 is identical, is in fact the same as angle X, Y, Z. Those guys are the same angle, angle X, Y, Z. And so you'll have a choice when you're naming your angles. You can either use a single numerical value, or you can use 3 letters. Alright. Now, and also, let's go one last thing, and then we'll stop at this point. Because again, there's a lot to this, and it's an interesting thing, but we don't want to overwhelm you the first time. Let's say that we're still dealing with the same one angle. You can use the single letter 1, a value, numerical value on the interior. You can have 3 letters that identify the angles by vertices, or 3 points that are on the angle, or the one last thing. Now this is a unique case. This only works when, in fact, that you only have a single letter here. You can, in fact, only because this is a unique angle, you can just refer to it by the vertex angle. So in fact, if you wish, you could also name this angle. This would be the same as angle Y. Now again, that's a unique case, and certainly that would not be the case if you have more than one vertex at a location. An interior letter, 3 letters can identify the angle, or it's just a single letter, and that single letter, that one letter, would have to be the vertex. Alright, that's enough for now. We'll take a look and pick up on more different types of angles in future videos. But thanks for visiting, and we'll look forward to seeing you on our next in our next video. Take care.